Ladies and gentlemen, we're on Unit 4, Lesson 7, and this is Building Quadratics Functions to Describe Situations, Part 3, or just modeling quadratic functions with story problems. Our warm-up is a which one doesn't belong and why. So if you just look at the graphs, you have to pick which one doesn't belong and then why. So what popped out to me right away was graph C. And then graph C I picked because it had dots. Compared to every other graph, it had lines in it. If I looked at graph A, it's horizontal. And graph B is also a linear graph. But what sets that apart from A and B is graph B has an increasing slope. And then examining graph D, it's a little bit harder to see, but graph D is the only one with a y-intercept other than 2. So the y-intercept is not 2. And then as we examine the other part, we have to look for the rate of change on the interval from 0 to 1. This means I look from x equals 0 to x equals 1 and find the slope. Now, if I go from 0 to 1 on this graph and I'm looking at the slope, we would do the rise over run. I can see that from this point to this point, I don't go up at all, so the rise is 0. And then although I went over 2 boxes, I only go over one number. So my run is 1 and 0 over 1 gives me a 0 slope. In fact, any horizontal line has a 0 slope. Same thing here. To go from 2 to 1 here, if I did rise over run, that's going to give me 1. And then I went up from 2 to 6, and 6 minus 2 gives me 4. So my rate of change, or my rise over run, 4 over 1 reduces to 4. For a parabola, on the interval from 0 to 1, again, my run is 1, but I go up from 2 to this number, which it counts 2, 4, 6, and then 8. So 8 minus 2 gives me an increase of 6. So my rise over run would be 6 over 1, which is 6. And then here, as I go over 1, so rise over run again, the run is 1, and then I go up 3.5 to about 7. So I go 7 minus about 3.5, which would give me 3.5 over 1, which is about 3.5. Okay, so ladies and gentlemen, our second task here, we have a company that sells movies online, and it's deciding how much they should charge to download the movie. So based on data, the company predicts that if they charge X dollars, so our input is X, the number of downloads is 18 minus X. So again, here, if the price is X, our downloads are 18 minus X. So here, if I had 3, what I did, I said 18 minus 3 was equal to 15. Same thing here, if I charge $5, 18 minus 5, when I substitute that in, I get 13. Similarly here, 18 minus 10 gives me 8, and 18 minus 12 gives me 6. 18 minus 15 gives me 3. And 18 minus 18 gives me 0. In general, if X is my input, in this column, the number of downloads is 18 minus X. So to calculate the revenue, we simply multiply. So revenue is a fancy business word, but that just means all of the money that comes in. So 3 times 15 gave me 45. And then here, 5 times 13. So the price is 5. We have 13,000 downloads. 5 times 13 would give me 65. If I have 10, we would see that 10 times 8 is 80. For 12, 12 times 6 is 72. For 15, 15 times 3 is 45. And 18 times 0 is 0. And then for x, it would be x is 18 minus x. So now we're asked, is the relationship between the price and the price of a movie and the revenue quadratic? So if I take the expression x times 18 minus x, some of you can see from the structure of this equation that right here, this x times the negative x will make x squared. So it is, in fact, quadratic. Some of you need to expand or distribute. So x times 18 gives you 18x. And then minus sign goes in the middle. X times x will give you x squared. And you can see from the expanded form that this is quadratic. Lastly, we're asked to plot a point. So here I can see if the price is 3, the revenue is 45. So I'm going to go at 3, you're at about 45. At 5, you go up to 65. At 10, you go up to 80. At 12, you go to 72. At 15, you go to 45. At 18, it's at 0. Now, in looking at this graph and looking at the table, I think that from the incomplete information, you should charge $10. But I'm not sure. We're going to learn more exact mathematical methods for solving that. So for our last section, we're just going to look at a graph of a quadratic function. This particular function is a of x equals x times 25 minus x. And what we're going to do is kind of look at some overall domains and ranges and how to express those. So on this graph, the domain in the negative direction could go all the way to negative infinity. So we can say this would go from negative infinity, and in the positive direction, that would go to positive infinity. We could also say, using that with an inequality statement, we can say x is between negative infinity and positive infinity. Or you could also say x is all real numbers. Now the vertex is the top point. So to figure out what the x coordinate is, if this is 10 and 20, I know that this is 15. But it looks like the x coordinate is exactly halfway between 10 and 15. So I know that that's going to be 12.5. For my y coordinate, if this is 120 and this is 160, I know that that's 140. And then I even have to estimate a little bit more. This is going to be 150. And this is really almost to 160. So I'm just going to estimate that that's 158. Again, you might have come up with a different number, which is fine. Zeros are where the graph touches the y-axis. So I notice I have 2 zeros here and here. So my zeros, I'm going to say x equals 0 and x equals 25. And then my rate of change on the interval from 0 to 5, that just means if x equals 0 to x equals 5, how much did my rate of change? It's just a fancy word for slope. how much should my slope go up? So slope again, we can just change that to rise over run. If I went from 0 to 5, I know that my run was 5. So I'm just looking from here to here, from 0 to 5, how far up did I go? So if I look at my rise, I went from 0 to 100. So if I went from 0 to 100, I can do 100 minus 0, which is 100. And then to figure out my slope, 100 divided by 5 gives me 20 evenly. Now, to describe our graph or the interval of increase, that's just saying when am I going kind of up the parabola. So if I notice the lowest number for the interval of increase is going to be negative infinity. And then we stop at the x value. That's kind of like at the top of the hill or the vertex. So it stops at 12.5. Notice that I use a parenthesis and not a bracket because at the top of the hill, the interval is not increasing. It's actually not decreasing either. It's 0 because it's not increasing or decreasing. So the interval of decrease is the x values when the graph is decreasing. So that decrease starts just after 12.5. And then for the x value, it's decreasing forever. So it keeps on going until x equals infinity. Now for our line of symmetry, I'm just going to sketch one. I could do a better job with a ruler. But there is our line of symmetry. So it is a vertical line. And I know that vertical lines always have the form of x equals something. We said the x coordinate of the vertex was 12.5. So x is always going to equal 12.5 here. And then I already did the rate of change. I just accidentally wrote that again. So go ahead and complete the rest of the problems, finding these key values, and that will get you ready for your skill quiz.